Hello geometers, this is Ms. Backfish, and today what you're seeing is 5 different problems I gave my students on coordinate proof and how to decide what type of quadrilateral you have. So we talked about how to do this, and it says for each of the following use the distance formula, the slope, or the midpoint formula. So those are the key ideas there in terms of tools we're going to use to decide what we have. To examine the properties of the quadrilateral to determine if it's a parallelogram, rectangle, rhombus, square, trapezoid, isosceles trapezoid, or just a quadrilateral. You'll need to show all your work on your own paper and determine as specifically as possible. It also says I have included a quadrilaterals flow chart in this lesson, so you can think carefully about the properties and relationships. When we're doing this, we have already talked about all the properties of quadrilaterals. So if that's something that you have not learned, you're going to want to look at that pretty carefully. So let me just show that to you here. And if you just Google quadrilaterals flow chart or quadrilaterals properties, you can find something very similar to this, I have no doubt, because that's where I found it. So going back to the problems we're doing today, the first thing I did on the first one was just a rough sketch, and it really, rough is truly all that's necessary, just enough to get an idea of where these things are in relation to each other. In other words, which points are above the other, which points are to the left and right of another. So here's my quadrilateral, D, E, F, G, and the first thing I like to find is all of the slopes of the sides. There are different ways you can go about this, but I like to start by finding the slopes. 2 reasons. One is I can see whether opposite sides have the same slope, which they do here, and the other is I can see whether adjacent sides have opposite reciprocal slopes, which would mean they're perpendicular, and they don't here. So now I'm going to draw some conclusions, and that's the first thing I said, is because they have the same slope, GF is parallel to DE and DG is parallel to EF, and it is a parallelogram. Now, as I just said, these slopes also tell me that I do not have any right angles, because adjacent sides, which means 2 that are next to each other, 2 that are attached, see these 2 join at G, these 2 join at D, etc., they would have to have opposite reciprocal slopes. That's what this is, opposite reciprocal slopes, to show me that they were perpendicular. Opposite reciprocals is like if this one was 2/5 and this one was -5/2. We don't have anything like that, so we don't have any right angles. When you're doing a coordinate proof with quadrilaterals, finding out what you have and finding out what you don't have are really equal parts of the puzzle. So I wrote out a little list and said, okay, I know that I have a parallelogram. And I know that by our definition of trapezoid, I don't have a trapezoid. We're going with what I kind of consider the old definition of trapezoid, which is exactly 1 pair of parallel sides. Only 1 pair of parallel sides. There is a newer idea that it's okay for both to be parallel, but I'm not going with that. To me, if both pairs of opposite sides are parallel, it's a parallelogram. And if only 1 pair is parallel, that would be a trapezoid. So we know we don't have a trapezoid by that definition. We also know now, because we have no right angles, it's not a rectangle and it's not a square. We also know we're not just going to call it a random quadrilateral because we already have a more specific name than that. So at the very least, it's a parallelogram, but it might be a rhombus. How could I find out if it's a rhombus? Well, there are a couple of ways. I could find out if I could find out if the 2 diagonals met at a right angle. If the 2 diagonals were perpendicular to each other. That's one way to know it's a rhombus, if I know it's already a parallelogram. Another way is I can find out if all 4 sides are the same length. To find out if all 4 sides are the same length, I'd have to do the distance formula 1, 2, 3, 4 times. To find out if the diagonals are perpendicular to each other, I have to do slope twice. Once for DF and once for GE. Slope twice is more efficient than distance formula 4 times in my book, so that's what I'm going to do. In case you were thinking, well, you already did the slopes. I did the slopes of the sides. We're talking about the dotted lines here, the diagonals. Remember that technically a diagonal is basically a segment connecting any 2 points or 2 vertices that are not already connected by the sides. So G to E and D to F. So I found those slopes, and here they are. What were we looking for? We were looking to see if they were perpendicular. That would be the whole opposite reciprocal slopes thing, and I do not have that. They are opposite, but they're not, meaning positive, negative, but they're not reciprocals. Like if this had been -6/5, or if this had been +4, then yeah. But these are not perpendicular. So I have ruled out rhombus because the diagonals of a rhombus are perpendicular, and I know that what I have is simply a parallelogram. You definitely want to make sure that you give enough work and even words of explanation in your coordinate proofs that someone who is reading it can follow your thinking. It's like, why did they find the slopes of these? Well, I found out that the diagonals, let's say, go ahead and put the diagonals were not perpendicular. And what did that tell me? It told me it was not a rhombus. So it's important to make sure you give just enough that people reading your proof can follow what's going on. Okay, so next we have quadrilateral ABCD with the coordinates shown here. And the first thing I'm going to do is my rough sketch. And there it is. And just like last time, I think I'll start by finding the slopes of the sides. So I'm going to say slopes, and I'm going to do all four sides so that I can see if opposite sides are parallel and if adjacent sides are perpendicular. Okay, so you notice I show a little work when I do this, even though slope is something that maybe you or I could do some of in our head. But there's two reasons I do that. Number one is anytime you're doing a coordinate proof, you want to show some work because your work is kind of your answer. It's your explanation. It's you showing that this is definitely true or definitely not true. The other reason is slope is a very easy thing to get mixed up a little bit, get something wrong in terms of signs if you're not careful, especially things like 2 minus a negative 1 or 6 minus a negative 3. So be very careful with your signs, and showing more work allows you to do that. Now, another thing I want to point out there is that your slopes, anytime you do slope, make sure it sort of makes sense in terms of positive and negative. Slopes or segments that rise from left to right should have a positive slope, like DC and AB. I should expect the slopes to be positive. And if they fall from left to right, I should expect the slopes to be negative. That kind of helps me catch myself if I do something wrong with signs. Okay, so what we can see here is that we have opposite sides parallel, and we also have adjacent sides perpendicular because 1/3 and negative 3 are opposite reciprocals. So what that tells me that I do have a parallelogram because opposite sides have the same slope, and so they're parallel. And then in addition to that, because they have opposite reciprocal slopes, I know that all four sides are perpendicular to each of the sides adjacent to them. And I just kind of went through and said in pairs all of these are perpendicular, so that means I have 4 right angles, and that means I have a rectangle. So going back to my little cross-off thing here, I know I'm not just going to call it a quadrilateral because we know it's more special than that. We know it's a parallelogram, but we also know it's a rectangle, so rectangle is more special than parallelogram, so I'm not even going to have to say that. I mean, you could leave it open, but I'm not going to call it that because I'm calling it a more specific type of parallelogram already. Now, since we know it's a parallelogram, it's not a trapezoid, it's not an isosceles trapezoid, it could still be a rhombus because we don't know anything about the side lengths. We don't know if all 4 sides are the same. And remember, even though it's a rectangle can be a rhombus because it could be a square. A square is a rectangle that is also a rhombus. So just like last time, I'm going to check to see if it's a rhombus by doing either distance formula 4 times to find out if all 4 sides are the same length, or slope formula twice with the diagonals to see if they are perpendicular to each other. And I'll go ahead and do that just because it is a little bit faster, is finding those slopes. Instead of doing both of them, I'm going to go ahead and stop right here. Now, I really should probably keep going if I'm doing this as an assignment, but I want to stop right here and point out to you that at this point I know my answer. All right, if I have a slope of 0 and I notice, oh yeah, these have the same y value, that's why the slope is 0, that's a horizontal line. DB is horizontal. The only thing perpendicular to a horizontal is vertical. The only way a line could be vertical here is if it also goes through -3, the other point does. Or here, if the other point also goes through 5, and I'm talking about the x value. Vertical lines are x equals. So this is not a vertical line, for sure. I could go ahead and do the slope, though, just to make my point. The slope of CA is 6/8 or 3/4. So these are not perpendicular, so it's not a rhombus. So that tells me the most specific thing. And by the way, a square is a rhombus, so that makes it also not a square. Most specific thing I can call this is a rectangle. As we start the next one, QRST, did you notice something about the coordinates? Do you notice that the y values are all the same? What does that tell you? Think about what that means before you graph it. Okay, old school edit here, because I was doing my graph. I messed up my graph pretty good, and since I'm using a felt tip pen instead of pencil, which I hope you're using, but it would not show up in the video well, I had to go back. I just didn't like it. But here's my rough sketch, and we have two horizontal sides. We have QR is horizontal, TS is horizontal, so those are automatically parallel. I still should probably at least say so. I could at least say, since QR and TS are horizontal, they are parallel. But if your teacher is old school enough, they're going to want you, let's say slopes, sorry, they're going to want you to show it. So let's go ahead and say QR, 7 minus 7 makes 0. It really doesn't even matter what's in the denominator. TS, 3 minus 3 makes 0. So horizontal lines have a slope of 0. Those happen to have the same change in x, but they don't have to be horizontal. So QR is parallel to TS. Okay, now let's look at the other ones. We have TQ slope, and that's 7 minus 3 over 6 minus 3, which is 4/3. And then RS's slope, and that's 7 minus 3 over 11 minus 8, which is also 4/3. So I know that TQ is parallel to RS. So far then, I know that I have a parallelogram, which says it's not going to be one of these others. I'm not going to say just quadrilateral. I'm not going to say trapezoid. I'm not going to say isosceles trapezoid. So now I just have to investigate to see if it is a rectangle, a rhombus, or a square. Now I know it's not a rectangle, okay, because opposite sides don't have adjacent sides don't have opposite reciprocal slopes. Another way of putting that for this one is because two of the sides are horizontal, the other two sides would have to be vertical, and they're not. QT, not vertical. RS, not vertical. Okay, so it's not a rectangle. We don't have right angles, which means it's also not a square. So again, I find myself checking to see if it's a rhombus. Let's shake it up a little bit this time, and this time let's go ahead and find all 4 side lengths to see if it's a rhombus. Okay, so how do I find side lengths? I use the distance formula. So let's look back at that real quick. Distance formula. The difference between the x values, the change in x squared, plus the change in y, or difference between the y values squared. Now notice we've been finding slope. We've been basically looking at the same ideas, the change in y and the change in x, just in a different context. So let me point out here, remember that when you have a horizontal or a vertical segment, you can count its length just by counting, because the y values don't change here. It's just going to be the distance between 6 and 11, which is 5. Here the y values don't change, just the distance between 3 and 8, which is 5. Notice we got a 5 right there. Okay? When we do these other two segments, TQ and SR, what the distance formula does is say the horizontal displacement, or the horizontal change between one point and the next, vertical change. Here's the horizontal change, here's the vertical change. This horizontal change is the same thing that we found right here. It's 3. Here too. It's the difference between 11 and 8. Vertical change here is the same thing we found up here. It's 4. Vertical change here, same thing we found up here. It's 4. So it shouldn't surprise us that these are the numbers that come up when we're doing distance formula. And because 3, 4, and 5 are a Pythagorean triple, remember that the distance formula and the Pythagorean theorem are basically siblings. They're basically the same thing, really. They're like fraternal twins. They look different, but they're the same thing. Okay, that's a Pythagorean triple, 3, 4, and 5. And that's what we've got right there. And right here, 3, 4, 5. Okay, so because all four sides are the same, we have our answer. And it's a rhombus. Okay, here's number 4. I did a rough sketch. I found the slopes of all the sides, and look what I've got. I've got opposite sides having the same slope, and I have adjacent sides having opposite reciprocal slopes. So I know that not only is it a parallelogram, it is a parallelogram with 4 right angles, so it's a rectangle. So let's say opposite sides are parallel, because we have the same slope. Adjacent sides are perpendicular because we have opposite reciprocal slopes. So we have 4 right angles. Okay. And probably a little bit like you, I'm getting a little bit less wordy as I do more problems. We keep finding the same conclusions, so we can assume at this point we have some idea what this means. All right, so because it has 4 right angles and is a parallelogram, well, even if it didn't have 4, I mean, even if it wasn't a parallelogram, if it had 4 right angles, that would tell us it was. You could leave that uncrossed out if we wanted to, because that is true, but that's not going to be what I end up calling it. So far, I know that it is a rectangle. I don't know if it's a rhombus. Okay, so again, once again, let's go ahead and check. And just like last time, let's go ahead and use the 4 side lengths. I'm going to go ahead and use the distance formula 4 times. Okay, so here we are, all 4 sides. I found the distance. I used the distance formula to find their lengths, and I got 5 for all of them. As you were doing this, I suspect you probably noticed the same thing I did, which is what we're getting here. This is 3, this is -4. You're getting 3 or 4 or -3 or -4 each time, and then you're squaring it, which means it didn't really matter whether it was negative or positive to begin with, which are the same numbers we got here. We got 3s and 4s all the way here. So it should be no surprise that they show up here as well. All right, so we now know, we already said it was a rectangle, so we have 4 right angles. We now know it's also a rhombus. Well, a rectangle that is a rhombus is a square. So that is what this is. And we could give a little bit more explanation there. We could say because it has 4 right angles and 4 congruent sides, or maybe just write 4 congruent sides, something like that, to point out we do have a square. Okay, so here's our last one, and it's a pretty interesting one. You notice that K and L have the same Y value, so those are a horizontal, those make a horizontal segment. And J and M have the same X value, so those make a vertical segment. So it looks a little like this. It's going to be interesting to see if JK and ML are parallel. We already know that JM and LK are not. So I'm going to say it's possible we have a trapezoid here, so let's see. Okay, so as I started to do this work, I went ahead and made a mistake. And again, I'm writing in felt tip, which is a little annoying. But I wanted to make sure you saw this mistake because it brings up something that I was hoping that you understood and going to address at the end of this video. When we do the slope formula, this is the traditional way that we write it. And what it's assuming is that we have 2 points and that we call one of them point 1 and one of them point 2. Okay? And it's really random which one is point 1 or point 2. They're not like, permanent names. It's just for the sake of the order here. Now, what does it matter with the order here? It doesn't matter which point you make point 1 and point 2. So it doesn't really matter which order you subtract in, as long as you are consistent. In other words, I could just as easily do this. It doesn't matter which point is point 1 and which point is point 2. It does matter that whichever order I do it for the y's, I also do it for the x's. And that was the mistake I made here. I did 7 minus 0 for the y values. So going from j to k, which means I also needed to go from j to k for the x values and do 4 minus 11. Now, how did I catch myself? Well, look at what I would have gotten had I done it the other way. That's a positive slope. This clearly falls from left to right. So that was what I was talking about earlier. If you see that it falls from left to right, you should expect a negative slope so that you can catch yourself if you do something like I did. And say, oh, okay, now I've got it. We're good. All right, let's go ahead and do the rest together real quick. Jm, there's no change in x there. So that's going to be a 0 in the denominator. What is a 0 in the denominator? That's undefined. Okay, it doesn't exist basically. Sometimes we say no slope. How about ML? This is the one I'm hoping is perpendicular to that. So change in y on top, change in x on the bottom, 3 over negative 3, yep, they are parallel. And LK we know is going to have a slope of 0 because it is horizontal. 0 minus 0 on top. 0 on top of a fraction makes it 0. 0 in the bottom of a fraction makes it undefined. 0 on top makes it 0. So we have one pair of parallel sides, exactly one pair of parallel sides, which means we have a trapezoid. So it's not a parallelogram. It's not going to be a rectangle, a rhombus, or a square because it's not a parallelogram. Could be an isosceles trapezoid, though, so we need to check that. What's an isosceles trapezoid got? It has opposite sides that are not parallel, but are congruent. In other words, we've got one pair of opposite sides that are parallel here. It would have to be the other pair of opposite sides that were congruent. So we need to find the lengths of JM and LK. There is another way we could check this. Another property of isosceles trapezoids is that their diagonals are congruent. So I could check JL and MK, those two lengths. But that's not any more efficient than what I'm doing because it's still finding two lengths. So I'm just going to go ahead and find the length of JM and the length of LK. Now remember, with horizontal and vertical lines, you could just count. But I went ahead and did the distance formula, and it still tells me that these two sides are congruent. So JM is congruent to LK. That's one thing I know. And then I also need to point out that JK is parallel to ML. And so I have an isosceles trapezoid. It's always a good idea to figure out how to spell isosceles. So I think of the word celery. For some reason that helps me. It's like it's got isos and then celery is in there, but there's no re. Hope that helps. Hope all of this helps, and I will see you next time.